All right, guys, we're on the back side of day 6 notes for Unit 7. And at the top it says, if it is known that two triangles are similar, usually by angle-angle similarity. All right, but remember that there are two other methods. There's side-side-side similarity and side-angle-side similarity. Okay, then a correct proportion. And remember that a proportion is just a fraction equal to a fraction, can be set up to solve for any missing side. The proportion must be set up using corresponding sides. So however you set up the first fraction has to be how you set up the second fraction. So number 4, it says that the company diagram shows two similar triangles. And if you notice the markings in them, they are similar by angle-angle similarity because they have two angles marked congruent in each one. Which proportion could be used to solve for x? And so we have to make sure that we're using matching sides. So in this one, we can clearly see that x matches with 15 because x is the side between the two marked angles and 15 is the side marked between two angles. Okay. If I go across from the single arc mark, okay, I see 32. So across from the single arc mark is 12. So those two sides will match up. And then my remaining side of 24 is going to match up with my 9. Okay. And so that's how I can set up my proportions. All right. So in the first one, they're doing x over 24. So we don't typically do that, but you can. All right. So x to 24 would be the yellow side first, okay, to the blue side. Well, if we do that, then the fraction that matches that would be the 15 over the 9. And you're going to see here, they flip that. They put the 9 on top and the 15 on the bottom, and we can't do that. Okay. So in number 2, okay, they have 24 set up over 9. So 24, okay, set up over 9. So that's, the light blue side over the light blue side there. So that's fine. Okay. Then they did 15 over x. So they went here first, okay, and here second. But then in the second fraction, they went here first. So you can't do that. You could do 24 over 9, but you would have to do x over 15. So again, this should be flipped around, and that's why that's not our choice. Okay. In number 3, they did 32 over 12. So 32 over 12, totally fine. And then they did x over 15. So they did 32 first, 12 second, okay? And then they did x first and 15 second. And that's fine. You can do that. 32 over 12 equals x over 15. So this is a correct proportion or a correct fraction equal to a fraction. Let's just take a look at choice 4 and see why that's wrong. They went 32 over 12, which we said is fine in the last one, but then they went 15 over x. Okay? If you're going to do 32 over 12, you then have to do x over 15. And so again, this should have been flipped around, and that's why that's not our choice. Okay, so that's just a little rundown on how to correctly set up a proportion. All right, so that if we actually have to solve it, all right, then we will be able to find our correct answer. In number 5, it says the diagram below, AF and DB intersect at C. And AD and FBE are drawn such that angle D is 65, angle CBE is 115, DC 7.2, AC is 9.6, and FC equals 21.6. So there's a lot going on in this picture. So in part A, they're going to ask us determine if the triangles are similar. And as of right now, what I see is that similar triangles, remember, have 3 theorems: angle-angle similarity, side-side-side similarity, and side-angle-side similarity. All right. Based on what I see is that these 2 triangles, and let's highlight them just so we can maybe see them better. This blue triangle here to this red triangle, they look like they have the same shape, just different sizes. Okay, but we have to prove it. We can't just go based on looks. All right. What I do see is that these 2 triangles are what we call tip to tip. All right. And then they would have these vertical angles being congruent here in the middle. Okay. So angle DCA is congruent to angle FCB. Okay, these are vertical angles are congruent. So that's one pair of angles. All right, so a pair of angles. Also, I see that they gave me another angle of 65 degrees here, but over here they didn't give me 65, they gave me 115. But notice this is a linear pair, Okay? Linear pairs add up to equal 180 degrees. And so if I take that 115 away, I'm going to be left with 65 for my interior angle. And so now I have this angle congruent to this angle. Okay. And therefore, I have my triangle similar by angle, angle similarity. So it says determine if the triangles are similar. And I'm going to say yes. They are similar by angle, angle similarity. Okay, and I have my work here to prove the one angle is 65 to match the other one, and I have my work here to prove my other angle, my other pair of angles are congruent because they're vertical. All right, so now part B says, what's the length of CB? So because these triangles are similar, their corresponding sides should be in proportion, which is a fraction equal to a fraction. So all I have to do is set up a fraction equal to a fraction, all right? Notice what they're asking me to solve for. They're asking me to solve for CB, so I'm going to put my X on CB. Okay? And then I'm going to go ahead and highlight my sides that match. So now I got to figure out who matches X. And so notice X is across from the angle we didn't mark at all. So across from the angle we didn't mark at all here is 7.2. Okay? So those two sides will go together. And over here, we got 9.6 across from that double marked angle. Okay? And across from my double marked angle is that 21.6. So that's how I figure out who matches with who or who corresponds to who. Okay? And so now I'm going to go ahead and take my X and I'm going to put it over the side it matches in the small triangle, which is 7.2. And that fraction should equal. All right, so remember what I did. I was started here with my X, then I went here. So in my second fraction, I have to start with the same triangle, but with the 21.6 and put it over the side it matches from the small triangle, because that's how I set up my first fraction. I have to set up my second fraction the same way. All right, if you want to flip the first fraction, you would have to flip the second fraction. All right, and then all we have to do, just like our warm-up, we cross multiplied. So this cross will be equal to this cross. All right, so my first cross is 9.6 times x, which is 9.6x, equal to 7.2 times 21.6. And 7.2 times 21.6 is 155.52. Okay? Then I'm just going to go ahead and divide by 9.6. Okay? And I end up with x equaling 16.2. And so now we can go ahead and say that CB equals 16.2. All right, so that if I put 16.2 up here and I divide here and I divide here, they should come out to be equal. All right, because they are similar, those fractions have to be equal. They have to have the same ratio. All right, let's take a look at number 6. It says in triangle CHR that O is on DR. I'm sorry, O is on HR and D is on CR. So that angle H is congruent to angle RDO. So that's one pair of angles. Okay. It says that RD is 4. RO is 6. And OH is 4. They want you to find the length of CD. All right. So I think that you see the triangles in there. All right. But this picture makes it very complicated to see them. So I'm going to take my little triangle here and I'm going to pull it out and redraw it. Actually, I think I'm going to redraw them over here. I got a little bit more room. And in that triangle, this is R, this is O, and this is D. And in the triangle, I have this angle already equal. I have 4 here, and I have 6 here. Okay. In my big triangle, all right, I'll redraw that one, but I'm going to try to redraw it so that it looks like this one. When triangles look the same, things are a lot easier to set up. All right. So remember that in the arc mark here that we have an angle D, I want that arc mark here, but that's at H. Okay. All right. Do you see how angle R is the same angle in both triangles? Angle R would match with angle R. So I'm going to put R there. Okay? And so in the yellow triangle, I have H and R, so the last letter has to be C. All right? But you can see they're matching angles. All right, in this triangle, what do we have here? We have HR on the bottom, which is 4 plus 6, right? Part plus part equals whole, and so that HR is 10. Okay? They want us to solve for this side, which is called CR, all right? And that's X plus 4. A little bit tricky there. Okay, but these two triangles are similar by angle similarity. They gave me the one pair of angles, and then we realized that angle R was the same R, so it has to have the same measurement in both triangles, and that makes the second angle. Okay? And so now we can go ahead and highlight our sides. Although, because we drew the pictures the same orientation on our paper, I don't think that we necessarily have to highlight. I think you guys can see that 4 is going to match with the 10, and that the 6 is going to match with the X plus 4. Okay? And so we'll go ahead and set it up. We have 4 over 10 equal to 6 over X plus 4. Or you could say 10 over 4 equals X plus 4 over 6. You can flip both of them if you want. All right, so just like in our warm-up, we can cross multiply, and we're going to get 10 times 6, which is 60, equal to 4 times X plus 4. All right, which is 60 equal to a 4X plus 16. We'll subtract 16, and when we do, we get 44 equal to a 4X, and we'll divide by 4, and X comes out to equal 11. Okay, and so when we put 11 back into our picture, we can see that CD is equal to 11. Now, if they asked us what CR is, we would have to do part plus part, 11 plus 4, and that would be 15. But they didn't ask for that. They only asked for CD. Okay, that was a tough question. All right, let's see if the next one's any better. It says, in the diagram picture, a flagpole stands outside of an office building, and Josh realizes that when he looks up from the ground, 60 meters away from the flagpole, that the top of the flagpole and the top of the building line up. So right here, we're going to go ahead and put a little stick person, and what they call him? They say Josh. So this is Josh. Okay, so when he looks here, he's 60 meters from the flagpole. Okay? And he also notices that the flagpole and the building, the tops of those line up. Okay. It says if the flagpole is 35 meters tall and Josh is 170 meters away from the building, they want to know how tall is the building. All right, so hopefully you guys see the little triangles there. So we have a triangle here formed by Josh and the flagpole and his line of sight. And all I'm going to do is take that triangle and redraw it just like I did in the last picture and relabel its sides of 60 and 35. Okay. Then I'm going to take the big triangle that I see and redraw that. Okay. And in this one, we don't know the height of the building, but we do know that this bottom side here is 170. All right. Now, why are these triangles similar? Because remember, you have to come up with that they're similar before you can set up a proportion or a fraction equal to a fraction. And the reason why these two triangles are similar is because the flag is 35 meters tall. That's its height, and height has to be perpendicular, right? When you go to the doctor, he tells you to stand straight up and down, okay? So that your body makes a right angle with the ground when you measure height. And so the height of the building is also going to be perpendicular to the ground, okay? The other thing we have to realize is that these two triangles, they overlap, okay? And so this angle where Josh is standing is going to be the same angle because it's the same angle in both triangles. All right, and so now we have the triangles similar by angle similarity, and therefore their corresponding sides are in proportion. So we're going to set up a proportion, okay? And we can go ahead and highlight, but I think you guys can tell because the triangles are drawn the same way that the 35 corresponds with the X and that the 60 corresponds with the 170. All right, but highlight them if you feel like you need to. Okay? And so we'll take our 35 and we'll put it over x. We'll go back to the first triangle, grab the 60, and go back to the second triangle and grab the 170. And we'll cross multiply, and we get 60x equal to 35 times 170, which is 5,950. And we'll go ahead and divide by 60. And now we have the height of our building, which is 99.1666, repeating. But good news, they asked us to round how tall is the building to the nearest tenth. So nearest tenth is the first decimal place we look next door. 5 or higher makes it go up, and so we'll say 99.2. And everything was in meters, so this will also be in meters. And we have the height of the building. Okay? All right, I will see you guys on day 8 note. We're going to skip 7. All right, see you guys there.